Hello again, grade 11s. What we're going to do today is put into practice our reduction formulae. You will recall that reduction formula is used to reduce a ratio of any angle to a ratio of an acute angle. So I will start off by looking at the angles 420 and negative 210 degrees. With any angle that is greater than 360, what you will need to do is subtract 360. I will do it step by step so that you are aware of what I'm doing at each point. Right. With the negative angle, what you would have to do in that instant is add 360 degrees to the negative 210 degrees. From there, we will now look at the trig ratios in the denominator. Looking at sine 115, I know that 115 degrees is in the second quadrant. Now in the second quadrant, it's either you'll have 180 degrees minus theta or 90 degrees plus theta. The most appropriate for this particular question is sine 90 degrees plus an angle, in this case is 25 degrees, which will then give us 115 when we add them together. I've chosen that because I see that there's something in the numerator that once I reduce the sine 90 degrees plus 25 degrees, I will be able to cancel out the 2. The next one is the cos 240 degrees. 240 degrees is in the third quadrant. In the third quadrant, I know I'm working with angles that are 180 degrees plus theta. So for this particular part, I'm saying 180 plus some angle. In this case, it is 60 degrees. Those two will add up to 240. Now in the next line, I will perform the reductions, right? What I will be left with is sine 60 degrees there, cos 25 degrees, tan 150 degrees. In the denominator, I will be left with cos 25 degrees and negative cos 60 degrees. Examining my expression now, I see that there are elements that I can cancel out, and there are also elements that I can further reduce. Now, sine 60 degrees, I can change that or reduce that using complementary angles. The complementary angle in this instance would be cos 30 degrees. The cos 25, like I had mentioned, we can actually cancel those two because they are common in the numerator and the denominator. Then the tan 150, now that is in your second quadrant. In the second quadrant, I know that I will have tan 180 minus 30 degrees, okay? In the denominator, what I'm left with is negative cos 60 degrees. Let us further reduce that. Cos 30 degrees in the numerator. Tan 180 degrees minus 30 reduces to negative tan 30 degrees. Don't forget your division line. Now the cos 60 degrees, okay, in the denominator here, I can actually express that again as a co-ratio or complementary angle, and that then becomes negative sine 30 degrees. Okay, Now I see that I have a negative in the numerator and a negative in the denominator. These two then become a positive. Right. Tan 30 degrees, that's an example of a fundamental identity. So I can, in essence, rewrite this as cos 30 degrees divided by sine 30 degrees, right? And this is multiplied by sine 30 degrees divided by cos 30 degrees. As you can see there, we can now cancel out cos 30 degrees in the numerator there with the cos 30 degrees in the denominator. The sine 30 degrees will cancel out with the sine 30 degrees in the numerator, and you are left with 1.